Spanish, working in France, so I have a kind of weird accent. I don't know if it's French, Spanish, mix of all. Probably it will be the less specific on serverless talk, because what I would like to present more or less is a use case. We are not working directly with serverless. We started to investigate what serverless is and what it can bring to us a couple of months ago. And what I come here is to present how and what we investigate and what we can do in BPM platform. Do you know BPM? Anyone who knows BPM? Business Process Management Platform. So, first of all, I have only 3 slides on pure serverless. So, first, when we start regarding watching videos and reading articles, first thing we more or less learned was that serverless was not, there's no servers, the servers are there. But it removes from the company the concept of maintenance, mainly if I have to summarize. It allows to focus more on the development, and it gives us the option to focus on really what matters. So in serverless, we have functions, and then we have the services to access these functions. So that's, if you start reading and you arrive for the first day and you start reading about serverless, you get that, and then you come to conference like that, and then you see, oof, I'm grown. So in fact, we just heard that serverless is not only functions, it's not only lambda, there are more things. So we started reading articles, we started investigating, and then why we did all of that? Because we have found in our platform, in the typical projects in a product like us, then I will go a bit more on details, that we have customers that were having specific needs. So first of all, we were, if you know BPM, it's a kind of low-code platforms that allow you to build applications, and then most of the people is interacting with your application, with your products or products. It's not the end users. It's not poor developers that they are going to do everything from scratch. But on the other hand, they are not sysadmins, they are not DevOps, and they usually have limited access to resources. So one of the things we saw that was that if we let our developers work with serverless, it can give us a benefit. Then we say, as we are. In fact, other things we learn about that on investigation, then I will go more in details, is that, well, it's on theory, if you read, it's scaling, it allows you to have a high availability, you have a distributed load, you don't have servers, you pay per cost. You pay what you use is your cost. But the only thing that really matters for me was this last line at the early beginning, was the isolated execution. Why I say isolated execution? Because the thing we're finding, and then again I will show you with a real example, is that in our case, we don't know what we are executing. Everything we have heard, every talk I assist yesterday and today, I arrived yesterday, we are focusing on developers that they are building your own applications, you are building everything from scratch, or you are migrating your platforms, but that's not my case. My case is I have an application and a developer, a customer is going to develop wherever he wants. We have customers who are in banking, insurance, healthcare, doesn't matter. So each function, each project, each process they are going to build will be completely different. And I cannot validate that what I'm going to execute is going to not kill my platform. So for me, the isolated execution was a good point. On the other hand, we have a cloud dependency, if it's private, public, you have Kubernetes, whatever, but I need to have something in which I'm going to run that. I have a limited execution time. In our case, we can be running pieces of code, and in theory should not be more than 5 minutes. If you check on Amazon, you have normally you just get 15 minutes. So it could be a count, it's not so big. Then response time fluctuates. We have warm-up, cold starts, etc. So in the same process I'm going to run, I'm not sure that every case will take the same time. And then it's stateless. Again, I saw one talk this morning, and stateless was busted. It was not something real, because you can keep kind of context between functions. But in my case, again, I was focusing on the part of isolated. So we arrived there, and we arrived to centralized distribute, and then we see that we have typical images of what a distributed or monolithic application looks like. And we say, okay, this is a monolithic. If we want to go to a serverless architecture, we have to go in that way. And then we arrive to the end of the investigation, quick investigation, and you say, okay, and now what we do? We discover that. Okay, now I will show you what we do. I'm gonna jump 2 slides. Now, I only want you to see that. That's our corporate architecture slide, and it looks pretty much like that. So we are monolithic. We have an application which is monolithic, which 99% of our customers are deploying on-premise. So why serverless can help us? What can we do with serverless that we can take benefit of that? There is a small piece, which is not really so small, which is all this section, which is called, we are going to call that connectors. If you don't know what BPM is, I'm going to show you a small process. BPM, it's business process management, and it's based usually all BPM vendors start by annotation, which is BPMN. It's from OMG, the same that did UML, and allow to design how my application is going to behave. It's going to allow to have interaction between end users and systems. So I will build an interface that will fill a form, I will submit some information, it's going to be treated, it's going to be calling an external system, a MongoDB, it's going to push some documents into a JET or a CMS, it's going to use some messaging queue, it's going to do whatever a customer wants. So here I have an example of a process that it's pretty simple, that one. It's going to handle the company payrolls once per month. So I will start my process once per month or on demand, and I will parse the file of the employees, I will handle the payrolls, then I will handle for each employee, I will build a document, send it by mail, and then I will send a confirmation to HR, Human Resources. It's kind of simple one. If I show you something, I have one open over here. This is a real process in production in a bank. It's not so complex, but this is to handle, I think it's loan request. You are asking for a loan in a bank and they need to go through different validations and connect to different systems. So again, I come back to the slides. So I have my process. I will have installed our application, Bonita, or whatever other BPM application. So I will have an engine that will be able to handle and convert one BPMN diagram into something executable. So I will execute that, I will fulfill a form, I will send information, and at some point I'm going to connect to an external system to do something. So what happened? If I'm building processes to handle vacation requests, to request for reports, something like that, we have a kind of normal load over the days. It will be split, and usually the same on-premise platform is able to handle it because it will consume from time to time CPU resource, and that's all. But we start having some situations in which you can have peaks. You can have regular peaks, like the payrolls, it's once per month, or you can have security alerts, something like that, that will trigger tons of instances per day or per minute. What we know, based on our experience on the products, is that even if we are not serverless in our architecture, the way it's done, it allows to handle, I don't remember the last metrics, but if you are not running any custom code, if you are only instantiating a process and executing tasks, you can instantiate around 1 million cases per minute. With 5 tasks, something like that, it's not doing anything. The problem comes when a customer adds his own code. So, what happens when we add this code? It happens that as the customer can do code, he can do whatever he wants. He can do a system exit 0. Well, that one, it's kind of covered. But he can do a Fibonacci, as I'm going to do in an example. So he can do a parsing of a file. He can build a file. He can use POI or Jasper, or he can do whatever he wants. And it will consume CPU, it will consume network, it can consume memory, depends. I have a customer. In fact, I'm going to show you later on a graph that for a given process to handle what is called DSN, en français c'est Déclaration Sociale Nominative, so it's Social Nominative Declaration for every single employee of a company once per month. They're going to have to handle of their customers, because this is an insurance company, so for every single customer they have, they will receive a file, they will need to parse it. For every single line, so for every single employee, they will need to connect to tons of different systems of the public administration to handle payments, to connect to banks, etc., etc. So what happened? For the biggest customer they handle, the consumption on memory, on RAM, is of 2 terabytes. Only one case. They are around 2 million customers. They have obviously small companies that has like 3-4 employees. But if you have big ones, it's going to be hard to handle. Then you have other situations, like I have another customer which is in Spain. This one is called MásMóvil. I don't know if you give you a name. It's a kind of Orange in Spain. It handles every day all the new customers that arrive, all the new services that they create, but in the night they do a batch because they have other 10 different sub-companies and they send all the information back. So they have a regular high load every night. Most of the consumption of resources are based on their code, not on the way of handling what's the moment of the process in which I am, if I process it that, if I call that service, if I store the information. It's the actions they are doing internally on their code, which is impacting the platform. So we say, why, if at some point we are able to let the customers, all customers, to instead of executing the code in the same JVM, to split it and put it out. So we start working on 3 hypotheses. Another JVM. We have a POC with RMI. I don't know if you know it. Even in the same machine or in different machines. With Docker directly. Or using, how it's called, I don't remember the name. But they are, with Docker. Or, that's the third hypothesis, is working with serverless. So we started working on building connectors that instead of calling a web service, it called a lambda function. That's the demo I did. It's a simple one, but it's only to show you the benefits short term. That's the first iteration of what we have done. We have gone a step away and say, everything you have today, we are going to take it and put it in a lambda function or a fast function, and we will let you execute whatever you want. We are still working on that right now, and it's not going to be on the products for next release that is this summer, but we work on that way. So there is the impact in terms of resource, but there are more things that this code block us. So in fact, the pain is first the scalability. We don't know if this our platform will be able to escalate, because we can escalate horizontally. You create a new instance of your service on Kubernetes, or you install a new node if you are on full premise. But if you are in that way, you will not be able to handle all the load if you have peaks. Then we don't have a way to know what's the resource consumption. Why that? We are on premise, you store, and that's all. Thing is, in parallel, we would like to have enough APAs. So how we invoice our customers. If we don't know what they are going to execute, I don't know what will be the consumption, so I don't know what I will invoice the customer. Then I have the concept of isolation or security. That's why I said before, we don't know what the customer is going to do inside. So what happens if it did an infinite loop? What happens if they call a system and the system is not answering and they have a thread with zombie? I don't know. And all of that link with the supports. Till where, in which moment I can tell the customer that's your problem, not my problem. It's your code, not my code. I have been working, I'm product owner since beginning of the year, officially, before I was doing something, but not officially. And I spent the previous 5 years working as technical consultant, meaning I was training people to use the tool, I was helping them to define their processes, but especially I was working as fireman. So I was in customer saying, I have a performance issue. I'm trying to execute 2,000 cases per day. It's not so much, but it takes more than 15 seconds to be executed. So you start checking their code, you start checking what we do, and then you start discovering things like you take one file, you parse it, you save it in memory, you save it in database, then you recover it, you parse it again, and you start doing this every single step you do. So that's not performance. What happens? If you do these kind of things, the rest of the platform is going to be blocked. If you consume CPU and you are in a single machine, everything is going to be slow. So we have an issue with our customers trying to say, hey, that's your problem, not our problem. If we are able to push this code and the execution of this code outside of our products, I think it's going to be more clear. So serverless or functions, based on the previous round table, I think it's more appropriate to speak about functions, could be an option. So this is an example of the insurance company I was telling you before. So here it's they had an execution rate of 1 case every 30 seconds. 30 cases per minute, so 1 case every 2 seconds. And at some point they start to pile, to grow the stock of cases without resolution. One by one, it doesn't take time. But as soon as they start compiling, we have a queue of work to do, and this is FIFO, first in, first out. If you have lots of things and you are not able to execute it fast, the queue is going to grow. When I worked with them, it was like 2 years ago, we discovered that they were doing this kind of parsing, as I was telling you, and then I was connecting to a MongoDB through REST, and it was taking like, with one case, it was taking like 100 milliseconds. When they have 20 calls in parallel, not so much, 20 calls, they were having response time of 1.5 minutes because of their system. So in that case, it's not our fault. We are calling an external system. So we did a first step on this orientation of connectors into serverless or functions or external code execution, which was do connectors completely asynchronous. If we go on details on how a connector, you can build connectors, you can do whatever you want there, it's Java code, you will see that it's more or less like the interface of a function. We are on Java, so it's like if you are building a function in Java. So you have a context, you have an output. We encapsulate it so you will have several inputs and several outputs, but we have it in a single object. So we could think on easily convert every single connector we have into a function. So, as I said, we have the isolation of the code, being able to scale, and being able, obviously, to reduce the footprint of the server. Right now, what happens? Everything is executed on the same GVM, so customers, they have a server with 8 core and 8 GB of RAM. They have a high load, and they have only one server because they don't want a cluster or high availability. I know we have customers that have like 64 cores servers with 64 gigas of RAM, which is used max 5% of the time. It's not going, almost every time it's not going up to 5% of CPU usage or memory. Or the memories grow and go down. Then, as I said, we are on Java, so you build your connectors in Java. If we start using functions, you can build your function whatever language you want. You call the function and that's all. You can take benefit of other functions, other services that are currently available, and you can call directly from your functions. And even it allows you to have your own services, if you have it in the cloud, and easily access from there. But especially we have the isolation of code. So the simplest way to call from a BPM platform to a serverless function will be using a connector. As I say, it's Java code, you do whatever you want. So that's what we did. We use lambda in this case. Not because of something special, only because we were using it for Amazon, for other things, so we started by that. And build a connector who is able to call the synchronous way or an asynchronous way to a lambda function, send a callback or no, and then get the file response or the call to the callback to get the output of the connector. So I did a really small example, as I say, with Fibonacci. So it's only a task who is going to call or a script which is going to calculate Fibonacci. It's a tip on the word. I don't know if you are familiar with Fibonacci. So it's only going to do that. I'm going to provide a parameter to say what's the number of Fibonacci I want you to calculate. And it's going to calculate it. And I did the same in a function I deploy on Amazon Web Service. In parallel, see. I'm going to execute this test. I don't know if you are familiar with Galdin. This is a Scala. I'm going to inject 200 cases, which is going to start one process and execute the task to calculate the Fibonacci in local. And I'm going to do the same calling the other one. Only doing that. Right now, all the math or the function it executes on the same JVM on my CPU. Right now, it's a simple case. Every time I increase the number of Fibonacci I want to calculate, or I increase the number of concurrent users who is going to try to execute, the response time is going to grow. It's going to take more or less 30 seconds. It has finished 3 cases, 10 cases of 200, and then it's going to go down. If I do the same calling a lambda function, I will have anyway a CPU usage on my machine. But the heavy load, it will be done outside. As I said, there are connectors for almost everything. So one of my big concerns is if I try to use a connector, I will see I have CPU is quite heavy. I have these connectors that we built, and we have connectors to database, to ERPs, web services, REST APIs. And as I say, you can create your own connector, as I did here, to call a lambda function. And that's specifically to lambda. So one of the things that I was expecting coming to this conference was to see what other options I had. So I was seeing OpenFast, I was seeing, what was the name? Don't remember right now the name of the other one. But my idea in the future of the products, I'm going to let the other thing finish, is be able to tell my customer, you can execute your code on your machines, or you can execute outside. That's for when they are working on premise. When we are on a cloud, and we are providing them as a service, the idea is everything is going to be executed outside. They will have data specific costs associated to them. But we need to be provider agnostics. Why? Because right now, okay, it's on premise. We have customers deploying on Linux distributions, on Windows. We have customers deploying on Azure or Amazon. So we cannot tie it. So if they want to execute functions on their Kubernetes, they will be able to do it. If they want to execute Lambda functions, Azure functions, etc., we need to provide them this option. But on the other hand, we want to make it transparent. BPM, the base of that, it's more or less low code. I say more or less because if you start from the beginning, BPM, it's for process management. It doesn't have any relationship with low code, but the market has joined. Right now, if you check Forrester Waves or you check Gartner, it's the same wave, it's the same magic quadrant. They join them. So we need to provide them an option in some way that they are able to execute Lambda functions or functions without knowing even that they are writing that. They have their code, and that's what we execute. in local or in remote. Sounds weird, but that's where we would like to go. And in the same way, as we are providing right now connectors, we would like to provide new functions and other kind of connectors that will allow them to get benefits on these functions. So I build a connector, which is the lambda connector, but again, it could be connectors to Lambda, Azure, Google. Could be for all the open source frameworks. Why not? And why not using directly a serverless framework? We can build their functions. The idea is that we are able to build the function behind the scene. They only write the code they want to execute. So all of that is good, but we didn't touch the architecture. So our product is still a monolithic application. So the incoming months, we will start discussion on, does it have sense that our application or BPM engine is serverless? Right now we have several limitations. We are really tight to the database. So almost everything we do, it's on the database. So if we go full on database, we will have to spend a lot of time on how we handle logs, how we handle concurrent execution, how we handle work distribution. And there are other things that we have started regarding all of that, which is the decoupling of all the small components. That's why I say at the early beginning we have 6 components on the same products, because we have development suites. You have the runtime execution who has all the interface system on the front end and on the back end. The back end has its own front end. And then you have artificial intelligence, and you have a module that will handle deployments on cloud, that will be able to have integration with Jenkins for all automatic compiling and deploying modules. Continuous delivery. In fact, it's called Bonita Continuous Delivery. So there is a long road. We just start. I wanted to share more or less what was my insights regarding serverless. Finish. I'm going to run the other one. And in parallel, small comparison. If I run it 200 times, that was the results I did on Monday. The same test. So I see that I have executing the same logic. To execute one task, it takes on average more than 1 second. And I have a regular distribution. If I do the same, calling a lambda, it's almost every time below 1 second. And I have everything stacked at the early beginning in less than 600 milliseconds. In the other case, I have 9 seconds, 33, 34, 39, 84. Why? Because I'm distributing the load. So if I check the JVM, first side, execute on my machine, my laptop, same number of instances calling a lambda function, take a bit less. So I allow my system to handle other things. And thank you all.